Yesterday we talked about inverse variation, so today would be only natural if we talked about the inverse variation graphs. So the first one we're going to take a look at is y equals k divided by x. So inverse means division, so y equals k divided by x. So it is asking you in your notes to graph those three. Why don't you go ahead and sketch those in your own calculator? So pause me, do that, and then unpause me when you have those. If you graphed them correctly, you should get these three graphs. So my red one is the very first one, which is 1 over x. The green one is the skinny one within there, which is 1 over 4x, as you can see in the green. And then the blue is -3 divided by x. So we have kind of seen this when we talked about domain and range, but these graphs are kind of broken in the middle, and they have the two different parts. As you can see, the negative on the third graph made it switch quadrants. Okay, so instead of being in quadrant, we've got 1, 2, 3, and 4. So the normal positive ones are in quadrants 1 and 3, and then when it switches to be negative, you're in quadrants 2 and 4. And then the 4 on the bottom, so the 1/4, the smaller number, made it the real skinny one. It went up a lot faster, and then the blue one was a little bit wider. So that's kind of the relationship. So we'll kind of talk about all of those notes. So the name of this is called a hyperbola. Okay, this is called a hyperbola. And note it has two branches. So we kind of talked about the fact that it has two branches. So we don't really say it has two parts. We say it's got two branches, and the branches are diagonal from each other. So like we talked about just now, it's either quadrants 1 and 3 or quadrants 2 and 4, and you're going to want to be able to talk about it in that way. The VA, okay, that stands for the vertical asymptote, and you can see the definition of asymptote off to the right. It means a line that the graph is getting really close to, but not crossing or touching. And we kind of talked about this indirectly when we talked about domain and range. But vertically, if you take a look at all of these graphs, vertically, what line are they not touching? Well, hopefully you see that it's definitely not touching right here, which would be the x-axis. I'm sorry, the y-axis. So the vertical asymptote is the x-axis. Sorry, the y-axis. The horizontal one is the x-axis. Okay, so it's never going to cross, and it's never going to touch either the x-axis or here on the x-axis. So x and y, it's not going to cross. Okay, numbers between 0 and 1. So again, we kind of talked about this with lines and parabolas. This would be a 1/4, a 1/2, a 1/3, etc. This time, these are your skinny graphs. Okay, these are the ones that go up really fast. Okay, they're really skinny. The number is bigger than 1, so the 1, 2, 3. These are your more gradual graphs. Okay, this is exactly flipped from your direct variation, which should make sense, okay? What happens to a graph should be kind of opposite now that we're dividing, okay? So since before 1/4, 1/2, 1/3 made it a wider graph, now it makes it skinny. Okay, k is greater than 0 is your positive ones. Okay, so if we kind of look back here, your positive graphs were both the red and the green. Okay, so what can we talk about it? So talk about domain. As we go left to right, where are we not going to see it? Well, we're not going to see it at that asymptote. So domain is x cannot equal 0. And then the range, vertically, bottom to top, is also going to be a y cannot equal 0. Hopefully those look a little bit familiar from when we did domain and range. There's a hole in that graph and it was at 0, 0. Quadrants, 1 and 3 we just talked about. Okay, so the positive ones are in quadrant 1 and 3. Okay, less than 0 is that negative graph. Okay, so that was my blue one here was a negative graph. So we can see that's in quadrants 2 and 4. And again, it's got the same idea about domain and range, it's just in the opposite quadrant. So x cannot equal 0 and y cannot equal 0, and that's quadrants 2 and quadrants 4. So those are the qualities of a hyperbola. So flip over, and the other one we're going to look at is k divided by x squared. Okay, so go ahead and graph those in your calculator, and then pause me while you do that, and then unpause me when you're done. So here are the graphs for y equals k over x squared. The red one is your first one, 1 over x squared. The green one is your second one, negative 1 over 3x squared. You're going to notice the negative flip quadrants again, and the 3 on the bottom made it 1/3, which made it a skinnier one, similar to the hyperbola. And then the last one is in blue, 4 over x squared. Just so we have this written down, I'll do my quadrants, 1, 2, 3, 4. So those are labeled for you as well. So we can talk about the properties of these graphs. The name of it, as it's written for you, is called the inverse square curve. Nothing short and sweet here. You need inverse square curve. Line of symmetry, kind of similar to the parabola. Where can you fold it over where it will land right on top of itself? Again, just like the parabola, that would be the y-axis. Vertical asymptote, VA. What line are these graphs? Okay, not going to touch vertically. Okay, again, that's that same idea right here. Vertically, they're never going to touch the y-axis. Horizontally, they're getting really close to, but they're not touching the x-axis. So again, this is the y-axis and the x-axis. Okay, note these, sometimes people call this the tree trunk, okay, but the branches are going to be side by side. So in a hyperbola, they were diagonal, and now they're side by side with the square. How do I remember it? Well, a parabola is an x squared, and the branches, so to speak, are right next to each other. So when we divide by x squared, the branches are also going to be next to each other. When we have something like 0 less than k less than 1, again, that's like a 1/2, a 1/3. Okay, these are your skinny graphs again. Okay, just like the inverse, the other inverse graph. Bigger than 1 was a 2 or a 3. These are your wider graphs. Just like the hyperbola, which is completely opposite of the direct variation, okay? When it's wider or skinnier, it acts completely opposite than a direct variation. K greater than 0 is your positive graphs. So my positive graphs were my blue and my red, and they are in quadrants 1 and 2. And if we talk about domain and range, domain left to right, we're going to see it everywhere, but we're not going to see it right at 0 where that hole is. Okay, so my domain is going to be x cannot equal 0. We said quadrants 1 and 2. Now let's think about the range. The range, okay, if I go bottom to top, I'm definitely not going to see it in this bottom area. I don't see any red or blue down here. I only see it starting here and above. So my range is going to be y greater than 0. It is not equal to 0 because it never actually touches the x-axis. So it's just going to be y is greater than 0. Kind of along the same idea, the negative graph, okay, the x is also cannot equal 0, but let's take a look at the range. Now if I'm looking at that green graph, I only see it here and below. I don't see the green above. Okay, so the green is going to be y less than 0. Again, not equal to because it's not actually touching. And then this is quadrants 3 and 4. So now we've taken a look at all the properties of both inverse graphs. Okay, so go ahead, stop and think. What is something you know? And what is something that you're still confused about? Today is a little trickier than the last graph, so please take a minute, reflect on what you just heard, and see what you're still confused about. And we'll go over those questions tomorrow.